Here are your solutions to guided practice. This is section 4-7, chapter 4, lesson 7. Problem number 1, they ask you to determine whether each table represents a linear or nonlinear function. So basically we need to find out if there is a constant rate of change. So of course we're going to check our x values, and we can look at it right away and see that we have a +1 in those cases, and then in the y values we can see that we have +2 here, and then from 3 to 6 we bump up to +3, and then from 6 to 10 we move up to +4. So this is a pretty quick, easy answer here. We're going to say that this is nonlinear and that the change in x is +1, whereas the change in y varies or is not constant either way. That is your explanation, because remember we need to explain here. Problem number 2, again we can take a look at the changes in our x. For x we can see that they're all +3. 0 plus 3 is 3, +3 is 6, +3 is 9. So then we can take a look at these values down here. From -3 to +9, remember we're looking at a number line. Let's say 0 is here, -3 is here, and all the way over here to 9, remember, is 12, so that's a +12. And then let's try this here. If we add 12 to 9, we do indeed get 21. If we add 12, we'll write it down here, to 21, we do indeed get 33. So we would say that this is, first of all, linear, because we have a constant rate of change. And then for our explanation, we would say that the change in x is +3, it's up here, whereas the change in y is +12. So we have a constant rate of change. It is a linear function. Problem number 3. The table shows the measures of the sides of several rectangles. So these are the side lengths. Here's the length of the rectangle. Here's the width of that rectangle. And then it asks, are the widths of the rectangles a linear function of the lengths? So is there a linear relationship here? Again, we're going to do the same thing. We're going to check from here to here to here. And here we have a +3. From 4 to 8 is a +4. 8 to 10 is a +2. So we're kind of all over the place there, but let's take a look down here. From 64 to 16 we drop 48. From 16 to 8 we drop, or I should say we subtract 8. And from 8 down to 6.4 we're subtracting 2.4. We really didn't need to do every single one of these, but I wanted to show you the complete process here. So clearly we would say this is non-linear, and our explanation is rate of change varies, or you could use the words not constant. The rate of change varies, the rate of change is not constant, shows that we have a non-linear function. Problem number 4, a cube has a side length of s meters. So if you imagine a cube looking like so, what we're saying here is that we have a side length here of s, a side length here of s, and a side length here of s. So it's s by s by s, so that would be s cubed for the volume. It would be s times s times s side lengths. The volume of the cube is a function of the side length. Does this situation represent a linear or nonlinear function? Explain. So the easiest way to do this is to set up a function table. We'll do it right here. We have an input of s and an output of volume. So we're going to have s cubed, for the volume is going to be s cubed. So if we input a volume of 0, of course we're going to have, input a side of 0, of course we're going to have a volume of 0. If we put in a side value of 1, 1 times 1 times 1 is going to be 1. If we put in a side length of 2, it's 2 times 2, which is 4, times 2 is 8. And if we put in 3 is as far as we'll go here, then we're going to have 3 times 3 times 3 is 27. So now pretend that they had created this table for us, and we can do what we've been doing all along and check what's happening here. Well, obviously we're adding 1 for our input values, our normal x values, and our outputs are not changing by a constant rate. Here it's a +1, then next it's a +7, and lastly it's a +19. So, is this linear or nonlinear? We would say that it is nonlinear, and to explain, we would say that the change in x is +1, but the change in y is not constant. Nonlinear. Problem number 5, building on the essential question. How can you use a table or a graph to determine if a function is linear or nonlinear? And we're going to go the easy way here and talk about this answer that was in the answer key. The table values indicate a constant rate of change between the x and y values in a linear function. So as we did above, if we've got a table here of values, in order to check here, we check from cell to cell, and if we have a +1, let's say, on this side, and a -4 on that side, and it's constant, we know that we have a linear function. If it's not constant, we have a nonlinear function. The graph of a linear function is a straight line that is not vertical. For example, if you see something here that graphs like this, we know that that's a linear function because it's a straight line. If we take a look at our graph and it's more like this, we know that it's nonlinear function because it's not a straight line.